In today's tutorial, we are going to learn how to insert a new node at the beginning of a single linked list. Before starting with the actual topic, I will just revise the concept of the single linked list first, and then we'll go to the insertion at the beginning of a single linked list. So, what is a single linked list? A single linked list is a series of connected nodes, and the nodes are connected to each other by a single link. That is the reason why it is called as a singly linked list. Nodes are there and these nodes are connected to each other by a single link. That is why it is called as a single linked list. Now, the nodes, so what is this node now? So node contains two parts. The first part is the piece of data. It can be of any type. It can be of character type, float type, integer type. So the first part is the data part. And the second is pointer to the next node in the list. Now, what is a pointer? Pointer saves address of another variable, right? So pointer saves address of another variable. So this second part will be a pointer. And the first part is data part, which is a simple variable. Now, this is I will show you the structure of a node. So this is the node. The first part is data, and this is a pointer that points to the next node. Now, in the codes which we will be discussing shortly, I'm going to use these two terms, data and the next part. So when you are writing codes, you can use any name, means you can give it any name to that variable. But in my codes, I will be using data in the next. So next it will be a pointer that is going to save an address of the next node. So this is the data and this is the next. Next will save the address of the next node. Now, the built-in data types that we have studied, okay, we have used it in a node. But these built-in data types, they do not allow us to combine the two attributes, that is the data and the next part, into a single entity. So we cannot use the built-in data types. Now we'll have to declare our own data types using structures. So we have already studied structures. So I'm going to show you how do we declare our own data types for our own data type for this node using structure. So the syntax is it will be struct the name of the data type. So in this case, this is a node. So I will give the name node, open the brackets, data. Data is the first attribute and the next is the second attribute. So we are clubbing this together, these two attributes together into a single entity called as the node. So first is data. Let's say the data type of data is int. It is of type integer. And next is next, the next part. Now, how are we going to declare the next part? Now, let's say I want to store address of an integer data. How will I declare the pointer? I will declare the pointer like this, int star ptr. So this ptr, there's an asterisk over here. So ptr is going to save an address of what type of data? Integer type of data. Similarly, in our case, this next is going to save address of another node. What is the type of that node? We cannot use the built-in data types for that node. So that's why we are declaring our own data type. So what is the type of that next node? It is nothing but struct node. Struct node star next semicolon, close the bracket and a semicolon. So this is how we are going to declare struct node. So this struct node is user defined data type, which we have declared for the node of a singly linked list, single linked list. It contains data part and the next part. So I hope this is clear. I'll go to the next slide. Now, a single linked list is a series of connected nodes. I've already discussed this. And there are two characteristics of a single linked list. The first character is a pointer called head pointer always points to the first node. So with the help of this node, with the help of this pointer, we can come to know that which is our first node in the linked list. So that helps us in maintaining, that helps us in tracking where the linked list starts, which node is the first node. So this is the head pointer, the first characteristic. And the second characteristic is that the last node's next part is always null. Last node's next part is always null. So I'm going to explain this. Before that, we'll just, as you all can see in this figure, there are there are uh, there are some slots which are not filled. I've not written anything in this slots. So now we are going to fill it. We are going to write in those free slots. So now here, see, this is the data part. The first node, this is the data part. And this 102, 113, 123, 132, these are all addresses. So I've just taken this for your understanding purpose. In the computer, the addresses will be in the hexadecimal, but I won't be able to write the hexadecimal numbers over here. So that is the reason why I have taken some plain integer numbers. So these are the addresses. So this node is at address 102. Second node is at address 113. Third node is at address 123, sorry. And the last node is at address 132. Now, the first part of a node is the data part, and the second is the next part. Next part is a pointer, and pointer variable saves address. So in this case, this over here, I'll have to write the address of the next node. Which is the next node? This with data item 8. What is the address of that node? It is 130. 130. Fine. Now go to 113. So we reach the second node. Now at this second node, I'll have to write the address of the third node. What is the address of the third node? It is 123. Fine. Now see, after writing 123, this link gets created. So this is called as a single link. That's why it is called as a singly linked list. Now go to 123, we reach the third node. Now I'll have to write the address of the next node. What is the address of the next node? 132. Now go to 132. 132. Now I'll have to write the address of the next node. But are there any more nodes after 132? No. So that is the reason why the last node's next part will always be null. So that is what this point says. Last node's next part will be always null. So these are the two characteristics you need to, these two characteristics are very important, and you need to remember these 2 points. And the head pointer points to the first node in a singly linked list. Now we'll see how to insert a node at the beginning of a singly linked list. So this is the linked list, right? Now I need to insert one more node over here. Okay, so before this 4 node, I need to insert another node. So that the newly created node becomes the first node. Now we'll start with that. Okay. So now we'll take this example. Now over here, this single linked list contains 3 nodes, okay, with data item 4, with data item 8, and with data item 10. Now we'll fill these empty fields first, and then we'll insert a node at the beginning. So for the first node is at address 1000. So what I'll have to write over here, the address of the next node. Address of the next node is 500. Now go to 500. Now over here, I need to write the address of the next node. What is the address of the next node? 600. Now go to 600. Now here, I'll have to write the address of the next node. Is there any other node? No. So here, I'll have to write none. Done. Now, I need to insert a node at the beginning of a singly linked list. So what I'll do is, first, we'll draw a figure, means we'll make the changes in this figure, we'll insert the node at the beginning, and then we'll write the code. We'll write statements for the changes that we are making in the figure. So let's say I have a node here. I have a node. So whenever you are creating a node, we need to have a pointer pointing to it. So here, see, there is a head. So here I've created this node, and a pointer called new node is pointing to it. And let's say the address is 2000 of this node. This new node is at address 2000. So I'll write 2000 over here. Now, this new node, okay, will have data part and it will have a next part. So this is called as a data part, and this is called as the next part. So how do I declare this? I will use the data type, that is struct node star new node. So for this pointer, new node is a pointer of type struct node. So new node has got a data part and a next part. Now let's say user has given 11. User has initialized this data part with 11 of the new node. Now I need to insert this at the beginning. Before this node 4, node with data item 4, I need to insert 11. Now here, this is empty, right? So what will I have to write over here? I'll have to write the address of the next node. So the first node in the previous case will become the second node. So address of the next node is 1000. Fine. Address is 1000. And one more change. Okay, so this is 1000. And then the first characteristics of single linked list, what it says, a pointer called head pointer should always point to the first node. So now in this case, the head pointer is pointing to the second node. So that is not correct. So what we'll have to do, we'll have to shift the head pointer. So see, now head is having 1000 value. Now I don't want 1000 over here. I need to have the address of the first node. What is the address of the first node? 2000. Okay, so when I do this, automatically a link gets created and this link is destroyed. Okay, and now this head pointer is pointing to a newly created node, and we have inserted a node at the beginning of a singly linked list. Now we'll write statements for this. Okay, so struct node star new node. Okay, so this is the first line. Now the next line will be, I'll have to declare, I will have to allocate some space to this new node. Okay, so now how do I allocate? Using the malloc function. So struct node star, okay, malloc. You people have already learned how to use the malloc function. So size of struct node. Okay, so this is how we write. Done. Now the next statement, okay, the next statement will be, I'll have to initialize this data part with level. Okay, so now we use the pointer. See, to this new node, a pointer called this node, a pointer called new node is pointing. So just write new node arrow. I want to initialize the data part. So I will write data over here is equal to 11. Now the next change, the next modification that we did in the figure was this 1000. It was empty. In the beginning, it was empty, right? So 1000, where is 1000 saved? 1000 is stored in the head. Okay. So now I'll use the same pointer new node arrow. It is I'm going to change the next part. I'm going to initialize the next part with this 1000. 1000 is there in here. And one more statement is remaining. I need to shift the head pointer. So earlier the head pointer was having 1000. Now it needs to have 2000. So 1000 in play. I'm overwriting this 1000 with 2000. So what can I do over here is new node goes into head. So this statements will insert a node at the beginning of a singly linked list with the assumption that already there is a linked list which is existing, and I'm inserting a node at the beginning of that linked list. If there are no nodes, I'll have to write few more lines. Okay, so I'll have to check. So before this, I'll have to check if head equal to null. No, I'll not equal to null. Then the statements will be executed. Else it will be new node goes into head. That's it. Okay. So this is how we are going to insert a new node at the beginning of the linked list. So now I'm going to show you the animation for this. Okay, so now here there are three nodes. See, there are three nodes over here, 4, 8, and 10. So here I'll have to write 500. Go to 500. Now here I'll have to write the address of the next node. So that is 600. Fine. Now 600, go to 600. Here I'll have to write the address of the next node. But are there any more nodes? No. So null. Now after that, see, I want to insert this node at the beginning. Okay. So now it is null. There is nothing over here. So in place of this null, I'll have to write the address of the next node. That is 1000. Okay. And then I'll have to shift the head pointer because the first characteristic, what it says, the pointer always points to the first node. Okay. I'll just clear these links. Okay, 1000. Then this link gets created. And now I will remove this 1000 and I will have to write 200 over here, the address of the new node. Okay. And this link gets created and this link will be destroyed. This link will be destroyed. So this is how we insert a node at the beginning of a singly linked list. So I hope this is clear. Thank you.